So we're all talking about conductance here, and conductance is either thermal or electrical, and it's talking about, well, how easily does energy transfer through an object? So if we're talking about thermal conductance, if you've ever walked on tiles in the morning versus carpet, you'll know that tiles are a much better conductor of heat. How can you tell? They feel cold. The tiles are colder than your body temperature, so you transfer heat quickly to the tiles. Carpet, on the other hand, it's probably the same temperature as the tiles, but because it's a poor conductor, you don't transfer heat out of your feet very quickly. Cool. The same thing applies with electrical conductance. How easily does an object allow electrical current or electrons to pass through it? In general, we need a certain type of material to allow that to occur. Metals tend to be very good conductors, while non-metals tend to not be very good conductors. So things like wood and rubber are really good things to be holding if you're going to touch something that's electrically charged, whereas a metal rod is probably not the best thing to be walking around in the lightning storm with. Okay? Most circuits we use, because we're trying to get a good conductor, because we want to try and keep our circuits as efficient as possible, we try and use good conductors to not waste energy. So for this we use wires, and usually copper wiring. So the question I've asked here is, do all copper wire, or does all copper wiring have the same electrical efficiency or the same conductance? And we determined pretty quickly that's not the case. Okay, and we went through that experiment where we had people walking through the corridor. It's impacted by length, thickness, and temperature. But how is it impacted? So we determined that as the electrons are walking through, or going through, in our case they're walking through the pathway, as they're going through the circuit, they bump into stuff. So the longer the path, the more they are going to bump into, which means the more resistance. So as length increases, conductance decreases. As temperature increased, so as we had our characters at the front vibrating more violently, was it easier or harder for our electrons to walk through the wire? Harder. So as temperature increases, conductance decreases. Okay, and thickness is a little bit tricky because we couldn't really change the thickness of the wire. What we could do is imagine we had those five, because we finished up, we had the 3 electrons trying to walk through the same pathway. Was that easier or harder than when we had 1 electron? Harder, because they had to bump into each other, they were bumping into the wire, they were bumping into a lot of different things, correct? So more current makes it harder to move. Happy with that? If we've got a thicker wire, do you think the current density will be lower or higher in our wire?
Lower.
So we're going to have less current per metre squared, aren't we? There'll be less people. If we had a thicker wire and we had 3 people, would they find it harder or easier? Easier. So as thickness increased, conductors increased as well. Are we clear with that? Now every now and then I was interchangeably throwing the word resistance in. So conductance and resistance are obviously very related. Conductance is all about what?
How energy can flow through it.
How easily energy can flow through it. What's resistance all about?
How
Yep, so what stops or how difficult it is for electrical energy to pass through it. So, what's the relationship between conductance and resistance? As conductance goes up, resistance goes
down.
And as resistance goes up, conductance goes
Down.